Hello students, so in the last lecture I was discussing about photoelectric transducers, and in that I was discussing about vacuum type photo MSF cells. So we'll continue with the same topic in this lecture also. So I was telling you in my last lecture that this circuit will be used for the measurement of luminous flux, or you can say luminous intensity, or you can say light energy. So how this circuit will be used, as I have told you in my last lecture also, that the photoelectric current depends on the intensity of light, or you can say the luminous intensity of light, the color or wavelength of light, and the voltage applied between cathode and anode. Now if I make any two of these factors constant, then luminous intensity will depend on the third factor completely. So what I will do, I will use a fixed wavelength light, and I will make this voltage constant. Then whatever photoelectric current will emit out because of the photoemissive effect of the light radiation will completely depend on the intensity, or you can say the luminous intensity of this radiation or the light striking the photoemissive material of this vacuum type photoemissive cell. So here I've shown a graph. Here the voltage, if you take the voltage constant for a constant voltage, suppose let me take this voltage constant, and for a constant radiation, if I make the radiation constant, what will happen, this anode current will completely depend on the luminous intensity of light. So here what I have done, I have made the radiation of the light, I have taken the radiation of the light constant, and here I have varied the anode current. If you can see the individual graphs here, the anode current is varied with respect to the voltage between the cathode and anode. So this is the one graph, again this is the another graph, and these are the different luminous flux. These are the different luminous flux or luminous intensity. Now if I make the anode voltage constant, we know the voltage, we know the wavelength of the light is already constant, and if I make the anode voltage constant, suppose this is the value I am going to take, what will happen, you can see for different luminous flux or different luminous intensities, the photoelectric current I am getting is different. So this anode current, or you can say the photoelectric current, is completely dependent on this luminous flux or luminous intensity when we make the voltage and the radiation of light constant. So this is the circuit. Here I will make the voltage constant, and I'll take a fixed wavelength light radiation. Sorry. I will take a fixed wavelength light radiation, and because of that the photoelectric current that I'll get will completely depend on the luminous intensity of the light energy. So this is the curve that is showing the current voltage characteristic that I've already discussed. Now there are various ways of actually measuring this photoelectric current, or you can say there are various ways of measuring the luminous intensity or luminous flux or light energy of the radiation using this circuit. So first is we can use a microammeter, which will measure the photoelectric current. We know the photoelectric current is completely dependent on the luminous intensity or luminous flux, so we can use a microammeter which will measure this photoelectric current, and ultimately we will get to know the light energy or luminous flux intensity. And this micrometer we can directly calibrate, since we know that this photoelectric current is dependent on this luminous intensity. If we make the voltage between the anode and cathode constant, and if we use a constant wavelength of the radiation, then this micrometer can be directly calibrated in terms of this this micrometer can be directly calibrated in terms of this luminous flux or luminous intensity. So this is one of the way of measuring this light energy using this micrometer, using this circuit. Now another way is that if I do not use this, another way is that if I use a voltmeter here, if I use a voltmeter here, this voltmeter will measure the voltage across this resistance. So what will be the voltage? E naught, this is the voltage, E naught is equal to IR. So here resistance is constant, I, this is the photoelectric current. So this will get measured with this microammeter. So E naught is the voltage. Since I, this photoelectric current, is dependent on the luminous flux or luminous intensity, and this output voltage is dependent on this photoelectric current, so we can say that this output voltage will determine or will tell you the luminous flux or luminous intensity, as this photoelectric current is dependent on the luminous flux or luminous intensity. So this is a transducer. As I've told you, this is a transducer because what it is doing, it is converting the light energy. This is converting this light energy into the electrical energy. It's photoelectric current into the electrical energy. So this is a transducer. So if I use a measurement system where I'll be putting this transducer, what will happen? I can actually use this output voltage, which is totally dependent on this luminous intensity. What is happening? This luminous light energy is getting converted into this electrical energy, and when this transducer is used in a measurement system, I can use this output voltage, that is electrical energy, for further amplification or for transmission, or for just like for I can use this transducer in a measurement system. Now next is photoelectric sensitivity. So what is photoelectric sensitivity? As I have told you that this luminous flux or luminous intensity, here I have described or represented the luminous flux with the symbol phi. So this optical transducer or this photoelectric transducer, what it is doing here, phi, that is luminous intensity, is the input that is falling on this photoemissive material, and the output is the current. This is the photoelectric current, I. So IB is the photoelectric current and phi is the luminous flux. So what will be the photoelectric sensitivity? We know sensitivity is equal to output upon input. So here IB is the output and I is the luminous flux or intensity. So it will be equal to photoelectric current divided by this luminous flux. So this is the photoelectric sensitivity. Now this phi can be expressed in terms of watt. That is then the photoelectric sensitivity will be called radiant sensitivity, and the unit will be ampere per watt. The unit of photoelectric sensitivity, which will then be called radiant sensitivity, the unit of that radiant sensitivity will be ampere per watt, because ampere is the unit of current and watt will be the, because this luminous intensity is expressed in terms of watt, so it will be ampere per watt. Now if the luminous intensity is expressed in terms of lumen, then the photoelectric sensitivity will be called luminous sensitivity, and the unit of luminous sensitivity will be ampere per lumen. Now we have this vacuum type photoemissive cell. So why we need this gas type photoemissive cell or photomultipliers? The actual reason is that this sensitivity, the sensitivity of vacuum type photoemissive cell is moderate. Why? Because of this luminous flux intensity. If I take the peak spectral, if I take that radiation, or you can say if I take that wavelength for which we will getting the maximum sensitivity or the maximum emission of electrons, if I take the radiation, if I take that wavelength of the radiation for which the electrons emitted will be maximum, so for that particular wavelength also we will get the sensitivity to be moderate, because the photoelectric current that will coming out will be in the range of microampere. It will be in the range of microampere. So the sensitivity is moderate. That is, luminous sensitivity will fall in the range that is 10 to 100 microampere per lumen, and for radiant sensitivity it will be equal to 0.002 to 0.1 microampere per microwatt. So you can say the sensitivity is moderate, and because the sensitivity is low, so for increasing the sensitivity we will search for more solutions, and then where we get this gas filled photoemissive cell and photomultipliers as the option. So this was the disadvantage of this vacuum type photoemissive cell, that the sensitivity of this type of cell is moderate. And what is the advantage? Now advantage of this photoemissive cell is the advantage of photoemissive cell is, if I operate this vacuum type photoemissive cell, if I operate this vacuum type photoemissive cell at a low wavelength, at a low voltage, if I operate this vacuum type photoemissive cell at a low voltage, and if I protect this cell against excessive light, then what will happen? For a very long time, this vacuum type photoemissive cell is going to show the stable characteristics. That is, its sensitivity will remain same for a very long time. So its characteristic is not going to fluctuate or get modified easily if I carefully handle this photoemissive cell. That is, if I operate this photoemissive cell at a very at a low voltage, and if I protect this photoemissive cell against this excessive light. So this is the advantage of photoemissive cell. And the disadvantage, as I've told you, what is the disadvantage? The disadvantage is its sensitivity is moderate, and because its sensitivity is moderate, in order to increase the sensitivity, that is, in order to increase the photoelectric current, I will go for gas filled photoemissive cell or photomultiplied tube. So these two topics I'll be discussing in my next lecture. I'm ending this class here. Thank you.